All right, so we're going to take what we have just learned about all the shapes and learn how to prove that a shape is a rectangle or a parallelogram or a square and so forth. So today we're just going to focus on parallelograms and rectangles. So a reminder, a parallelogram has two pairs of opposite sides that are parallel. Okay? So in other words, on this drawing, AD and BC are parallel to each other, and AB and DC are parallel to each other. I can prove this by showing their slopes are the same. Now remember, slope is y minus y over x minus x. This is going to come into play later with a little shortcut I'm going to show you. But remember, when we have a drawing like this, we can simply just count the slope. Okay? So for instance, DA, if we just count 1, 2, 3, 4, 5. So the slope of DA is up 5, right 2. We could have also gone down 1, 2, 3, 4, 5, and left 2. But remember, negative divided by negative is positive, so it's the same. Well, guess what? BC, 1, 2, 3, 4, 5, 1, 2. Also 5 halves. So we can prove that these two are parallel. And DC and AB are easy because they're horizontal lines, so we know they're parallel. They both have a slope of 0. So, reminder, properties of parallelogram. Both pairs of opposite sides are congruent. We can show this by doing the distance formula on opposite sides. So that's the square root of x minus x squared plus y minus y squared. Now remember, we said there's going to be a little shortcut. Well, this number when you count and this number when you count can just go in there. So for example, on the upper one we just did, we could say the square root of x minus x, well, we know that's 2 squared, plus y minus y, well, that was the 5 squared. So that's the square root of 29. So it's a little shortcut. And we'll practice that. Now remember, the diagonals bisect each other. Not going to require you to do that, but you could use the distance formula also to measure the parts. Opposite angles are congruent. Consecutive angles are not congruent. Consecutive angles are supplementary. That's a mistake. So let's go ahead and fix that right now. One pair of opposite sides is both congruent and parallel. So if you just know one pair is congruent and parallel, you can stop there. So if you do the distance formula and slope on one pair of them, you can stop. You don't have to do all 4 sides. All right, use the slope to show it's a parallelogram. So for AD, we just did this, okay? So this was 5 over 2. BC was 5 over 2. DC and AB were both 0. Are both pairs of opposite sides parallel? Yes. Why? Same slope. Hit pause if you need it. Now, use the distance formula, this is a new one, so we're going to do our little cheat on this one, our little shortcut. Now, TY and EP are easy. You can just count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Nine. Let's see. Hold on. Okay, just want to double check with myself. And so we're okay. So TY is 8 and EP is 9. So right off the bat, we already know. We can stop. The answer is no. Now, let's do the distance on the other two just for practice. So on YP and ET. Now remember, we're going to cheat. Instead of having to actually do the formula, let's just do the slope. So T to E is 1, 2, 3, 4, 1, 2. Okay? So TE is 4 over 2, right? So we just put those numbers in parentheses. And then Y to P. 1, 2, 3, 4, 1, 2, 3. So this one is 4 over 3. So that's going to be 4 squared plus 3 squared. So YP is going to be the square root of 16 plus 9, which is 25, or just 5. And this one is going to be square root of 16 plus 4, which is 20, which is 4 point something. So the answer is obviously no, because they do not have, one, they don't have opposite slopes the same, all right? TY and EP are the same, but YP and TE are not. We can see that right here. And the distances aren't the same. So sometimes we will get a no, and that's okay. Now, to prove a quadrilateral is a rectangle, use the slope to show that consecutive sides are perpendicular. So that means opposite sides and reciprocal. That means flip the fraction. So remember, that would be like 3 over 2 and negative 2 over 3, for example. So let's put these on our graph. So A is at 1, 3. B is at 4, 5. C is at 8, negative 1. This one's going to be a challenging one, so you can't just count. And 5, negative 3. So do our best to draw a rectangle type shape. We'll have to prove whether they are opposite reciprocal slopes. So B is here, C is here, and D is here. So let's do AB. Well, let's do AD like it says on there. So AD, we're going to count. 1, 2, 3, 4, 5, 6. Down 6. Right 1, 2, 3, 4. So that reduces to negative 3 over 2. Let's do BC. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Same thing. Negative 3 over 2 reduced. Remember, we first went negative 6 and then right 4. Down 6, right 4. Now let's do DC. This one is going to be 1, 2, up 2, and right 1, 2, 3. And from A to B, 1, 2, 1, 2, 3. Now you're not going to believe me, but it's not exactly the same. I just picked these by random, and they were pretty close. So if we compare negative 3 halves and 2 thirds, yes, they are perpendicular because they are opposite and reciprocal. Is ABCD a rectangle? Well, notice also we have opposite slopes that are the same. So yes, it's a parallelogram and a rectangle. Okay, last one. Plot the points and see if it's a parallelogram. So 1, 3, 8, 4, 9, 9, and 2, 7. So this is A, B, C, D. So let's find the slope of AD. We just count. 1, 2, 3, 4, up 4, right 1. Positive slope. BC, 1, 2, 3, 4, 5, right 1. So right off the bat, we already know. No, they don't have the same slope. But let's keep going. DC, 1, 2, 1, 2, 3, 4, 5, 6, 7. So 2 over 7. And from A to B, 1, 1, 2, 3, 4, 5, 6, 7. So the answer is no. The opposite slopes are not congruent. And there you go.